I'm going to start up this digital storage scope software and do a rundown on it. It's a Hantek 1008B, and this is what you have at startup. You'll be presented with the 8 inputs of the scope. As you can see, number 1 trace at the top. I have that actually plugged in. I'm just going to plug it onto a square wave generator here. And as you can see now, it's generating a square wave. The specifications on it is an 8-channel oscilloscope. It will display 8 channels, but you won't get much detail. In practice, I've had 3 channels on it, and I can view this waveform if you're not looking for much detail. I'm going to add another trace onto it now. And you can see there, number 2. Let's change the frequency of this a bit. And I'm going to add a third one. Okay. So we have 3 inputs at the moment connected. We have 8 channel inputs now at the moment, and what I'm going to do is I'm going to turn the other traces off. I'm only going to leave 3 connected up. And how you do this on the Hantek is you got to select a channel and click the off on each channel you don't want, and as you can see, they start disappearing. It's a bit of a pain. I'd rather have it come up with no traces and you select the amount of traces you need. Once you do this, it will remember the last setting you had. Now we have 2 traces up. You can move your traces about by bringing your cursor over the number on the left hand side, holding your left button on your mouse, and you can drag it down to where you want to display it. Bring the number 1 down. The software does come with the ability to capture your waveforms and save it as a picture for set up a reference library for yourself, and it also has the ability to record the signal and play it back. And we're going to just go into you can pause the data now, and it will freeze the data on screen. What you can do now is go up here and you can say save image. Okay, and as you can see, you can have it either save it as a JPEG file or a BMP file. Let's just do a JPEG file, and we'll just give it a name. Give it a waveform record. Right, and we'll save it. That is now saved, and if you want, you don't need your to display that saved picture. You don't need your digital storage scope up and running. You can just go to cars, and here we are. You can see there it's a JPEG file. There it is. Took a bit of time. That could be put in a reference library in your in a folder for your modelling car or electrical equipment you're repairing. Okay, you can start capturing data again by just pressing the play button. You have here on your right hand side your trigger point. You can select what waveform you want to trigger on by coming over here to the right hand side, your trigger source. Channel 1 is selected at the moment, so if I just drag that up, I can say I want to trigger the waveform up here, and that should make it steadier. Now if I come up here out of the way, let's see what happens. The trace moves across the screen, so I'll bring it down here, and it should keep that waveform steady in one place. It also has a delay up here that you can bring your waveform, move your waveform across. Your triggering point will move forward with it. It's useful if you have a waveform, you want to move it back and forth, you want to see left and right. You also then can trigger on the positive slope or the negative slope. Right now it's triggered on the positive, the rising edge of the waveform right here. I can trigger it here by going to the negative edge. Now you can see it triggers on the negative edge of the waveform. To change your triggering channel, just go to here to channel 2, and if you notice here on the right hand side your trigger icon changes colour to match the waveform. It is alright. Now we are now triggered on the input 2, and it's triggered on the negative goals waveform. We've also got auto, normal or single. I'll just switch them off. Yeah. So now we're left with just our waveform 1. Back up here. Increase this a bit too high. Alright. You see now I'm set to 500 millivolts per division. So from here to here is 500 millivolts. Now I'm going to just select my I'm going to trigger number 1. I'm going to trigger on the positive going slope, and I can move my trigger position around. Now my waveform is steady. You have the ability then to put measurements, digital display measurements on the bottom of your screen here. Just edit measure, and we're just going to stick with channel 1 for now. You can select channel 2, 3 and 4. You can add data to them if you had them up. So like we want to just put minimum and maximum voltage waveforms. Close. It's given me maximum voltage of 1.94 voltage, 1.94 volts, and a minimum of about somewhere between 170 and 137 millivolts. It also has cursors in here as well to do measurements for you. You can see we have this. Let's start with the cross. like this. It will measure the voltage between here. I'm just going to get a better measurement. So right, we're going to move from here. And it's going to give me, okay, that cross here reference or cursor gives me the voltage difference between the top level of the waveform and the bottom level of the waveform. It also gives me the time period between this point here, rising edge, until you go here. That'll be one cycle. And you can see down here at the bottom the time is 1 millisecond, roughly about 1 millisecond, and the voltage is 1.98 volts. Okay, we got another cursor. It's got a trace, and what that does is you move it back and forth. It just gives you the voltage level as you move it across. It's at 97.7 millivolts at the moment. You bring it over, and right there now it's kind of switching back and forth. It doesn't know what to do, but you move it back to the left, and it's giving me 1.94 volts. It's useful if you want to get a quick reference to the voltage levels. Like I could just bring it back and forth real quick. I can see that's the voltage on that. Bring it over here. I can see it's what voltage is there. Now we got the vertical trace. Alright, we can pick a spot where we're going to measure from. This will be mostly for time. So you got that there, as you can see. The crosshair does this as well, both of them in one go. As you can see there, that's 1 millisecond. What it doesn't give me is the voltage level, like the crosshair type cursor. Now we got the horizontal. So I go down here, click on there, and press the left button on the mouse and hold it down while I'm moving the mouse up, and select there, and that gives me 1.96 volts roughly on that waveform. So we just go back to your measurements. We can add more things to this as well if we want. Let's just give it a frequency, and as you can see, the frequency on the bottom left hand side is 1 kilohertz, 1 kilohertz, and the period is 1 millisecond. Which is the measurement we had earlier on when we were using our time reference, using the vertical trace, vertical cursor, or the cross cursor. It will also give you duty cycle. As you can see, this is really a 50-50 duty cycle. The pulse width, 500 microseconds, which would be right. 500 microseconds times 2, and it will give you your RMS value as well, which is 1.35 volts. We'll just leave the minimum and maximum on there at the moment. Get rid of everything else and close it. The Hantek software has the ability to record the live data as well, but it's pretty difficult to see from here, and it's hidden down the bottom right hand side. And you go onto this bar, just click that and scroll down, you have this. What I normally do is I click on this and I give the name we give it 5, and it's a recorder type file. That's all you're allowed to do. And to start recording, what you have to do is press this icon here, the start button, and it will start recording. I'm just going to do that now. And it'll tell you you can't change any of your settings. If you change any settings of this, the time base or the voltage heights or anything like that, or move anything, it will stop. So you got to leave it as it is. And when it's recording, you'll see this up here. It's recording, little tab up here on the left hand side. And it's quite useful. And what I'm going to do now is I'm going to just pause the video, and I will just let it record for a while, and we'll see what happens. I've been capturing this waveform now for the past few minutes. What I'm going to do now is I'm just going to click on the stop icon, and I get this warning message, the same as the messages I got when I started to record. I'm not too sure why you get it. It's probably a software problem. What I'm going to do now is I'm going to click on playback. And normally what you would do is select your waveform that you want to play back. I'm going to click on this one, just want to be done. And what I'll do now is just click start. And as you can see, we're playing back now. What we can do is pause that anywhere. Okay, we're paused. It is doing it very fast, so I'm just going to click stop for a minute. What's going on here is this here intervals. I normally go here 1 second. Yeah. That looks a bit more normal. So you can pause that signal, and then what you can do then is click on the zoom button here and just bring your cursor down to the screen, and it will zoom in and out. I've found in practice it doesn't zoom in very well. You can lose a bit of detail, and it has another problem when I'm zooming out. This is what you get. So you got to carefully consider how far you want to zoom in before you start recording. If I want to change my time base to capture more detail in the waveform, and I record at that time base, and then I want to zoom back out using the zoom function on the scope, this is what will happen. You're only going to see a couple of waveforms like that. I will demonstrate that to you now. I'm just going to click on stop, and just click on play there, so that captures my on-screen data. I'm just going to go back up here. You have to scroll back up, which is a bit of a nuisance. Get more detail. Okay, so we got a nice bit of detail there now. So we go back down here. Start a new file. Go on here to storage. Click on start. You give that a few minutes recording, and I will get back to you then. I'm just going to pause the video. I've recorded a few minutes now. I'm just going to click on the stop. And I get this warning. Click on playback. And I'm going to click on pause, because that's what you would do. You wanted to examine the waveform you captured. And let me see, I'm going to zoom in. We can zoom in good, no problem. What we can do then as well, if we want to drag the waveform over, is use this function here. I'll just do that again. This function up here at the top, drag waveform. I prefer if it had steps on it, or you could select a part of the waveform and zoom in, something like the Picoscope, but that's why you pay the big money for the Pico. So we can see here we're moving in steps of 1000. We've only got a memory length of 1600. So we just change that to just 10. Okay, you can see there it just moves back and forth. So you can look at the waveform, which is quite good actually to be able to do that, especially in the auto trade. And there we are at the end of our capture, really there. 1600. Let's get back to Sumber. You can go to each end of it as well by doing that. Here's the start. Okay, I'm going to go to speed it up a bit. Right. Now we want to zoom out and see more waveforms. You can see there is a limit, and that's one of the problems I've found with this. But if I zoom out, I will know that's all I will get. I'll be only able to see the amount of waveforms that is on the screen at that time. Unlike some of the more expensive software. Zoom back in. And you also got your do it here. But you can do your steps here. You can do it here as well. Okay. We also got up here specifically for the motor trade. You got this icon. You can pick any of these here you want. Engine, ignition, startup and charge. Come on here. Relative compression test. But you would need a current clamp for that. Or you want to be you could monitor the voltage drop on the battery and make it AC coupled. Injector, petrol. We're just doing petrol. And you got the different types of petrol injectors. Injector voltage and current, injector current and primary ignition, multi-point injector, single point injector, single point injector current. You get all the different time bases automatically set up here. You got your airflow, air vane, roll type, your camshaft sensors. These are the different types: inductive, AC excited, Hall effect, crankshaft, similar to the camshaft. And then you've got your distributor, the different types of pickups that you would see inside the old distributors. Raw 2 sensors, if you wanted to check your raw 2 sensor, direct wires on the sensor itself, because the data you see in the scan tool, it's not fast enough to update quick enough. Your throttle position, bus diagnosis, all the different CAN buses for doing tests. Your alternator. It does quite a lot for the £100 sterling that you would pay for this digital storage scope and the software. Software is limited, but it will show up a fault. It is quite good. I have used it quite an amount lately. You can print your screen, save it obviously. You can change your background colour to whatever colour you want. Click on it and you can select your colours, say white, and there you have a different colour screen. I'll leave it at the back, it's just easier. I can't get this DC to change to AC coupling. If someone knows how to do that on this software, please just respond. Okay, I'm going to select my single shot, try and capture a waveform. I'll set my trigger point up to just under the top level of the waveform, and I've moved my delay over here nearly halfway across the screen. I'm going to just connect my scope up to channel 1 input now, and as you can see, it captured that waveform. And as you can see there, this must be just as I move the scope close to the square wave generator, and then when it actually made contact, you have it here. I'm going to zoom in a little bit now, see if you can get any detail. Tell them. As you can see there, that is supposed to be a square wave, and this is what one of the problems I find with the Hantek. If you're zoomed out like that and you zoom in, you lose a lot of the detail of the waveform. That's not a square wave, it's more like a TPS signal. I hope that's of some benefit to someone out there using this software. It's not bad for its price, has limitations with the zoom functions. It's very hard to get detail when you zoom in, and if you zoom out you lose a lot of the waveforms. Just get the screen capture, that's it, you don't get any more. Thanks for watching.